Hello everyone, my name is Smit Baua and I'm an application engineer for electromagnetics with Altair Engineering. In this video, I will demonstrate how one can perform co-site interference analysis using Feko and RAP. The workflow to perform such an analysis involves two simple steps. The antenna coupling results from any platform can be fed to RAP by computing S parameters from Feko. Let's take an example to demonstrate the workflow. In this example, we will perform co-site analysis with three different antennas placed on an aircraft as shown in the image. The UHF blade antenna is placed on the bottom of the fuselage. The VHF blade antenna is placed on the front top of the fuselage, and the GPS receiver is placed far apart on the rear top side of the fuselage as shown in the image. All the antennas are designed and optimized in Feko. The radiation pattern and the reflection coefficient are observed as a standard output in the post-processing step in Feko. The effect of radome is also accounted for while doing this analysis, as you can see on the slide. We simulate the problem at three different required frequencies and observe the S parameters which are computed as a part of standard output. The next steps would involve setting up the problem in RAP. Once the RAP user interface is loaded, our first step would be to define an antenna. This can be done by going to the Equipment tab and creating a new antenna. Here is an example of an ideal isotropic antenna we have defined. Verify that the antenna diagram is 0 dBi in all directions. You can also inspect other settings. The next step is to define a transmitter and receiver. Transmitters and receivers can be defined from the Equipment tab. In this example, we have two transmitters and one receiver. We name the first transmitter as UHF Traffic Control Military and set the power to 30 watts. Specify other settings as shown. Similarly, we define one more transmitter that will be named as VHF Traffic Control Civilian. We also add one receiver representing the GPS L1 receiver. Specify the frequency characteristics of the transmitter and receiver individually and inspect other settings under different tabs. Once they are defined, save the project. To access the coupling loss matrix, which we need to enter the values from Feko, the stations have to be in a group. The map window can be accessed from the window menu. Right-click on a location of your choice in the map and select New Group and Transmitting Position. When asked to select a template, click Empty. After naming the group, we can define the stations on the Station tab. In this example, we have defined three stations as shown. When defining a station, we enter the name, coordinates, frequency, and other parameters as shown. With similar steps, we define new station as Blade VHF, Blade UHF, and GPS L1 receiver as shown in the video. We can make the stations visible on the map window if not already by right-clicking on the station in the project tree and selecting Show in Map Viewer. After all the stations are defined in a group, the next step is to specify the coupling loss matrix. In the project window, expand the groups in project, click sites in project, and double click on the group that we have created. Note that RAP has already provided some values in dB based on internal propagation calculation. Replace these values with Feko as shown in the video. The next and the final step is to set up and run the co-site interference analysis. From the menu, select Tools and select Co-location Interference. In the project window in the tree, multi-select the 3 stations. Inspect the settings. Include 12 harmonic orders as shown in the video and click on OK. Once this is done, click on Calculate and calculate interference. Once the results have been computed, select the receivers to observe the co-channel interference and the harmonic interference as shown in the video. After inspecting the results, we can derive final conclusions. The GPS receiver always suffers from the presence of transmitters around it. It suffers from both adjacent channel and harmonic interference, as we can see in the results. We see high adjacent channel interference between the GPS receiver and the blade VHF transmitter, even with a larger separation. In this particular configuration, we also see that there is no interference between the VHF and the UHF systems. Thank you for watching this video. For more details, please refer to the step-by-step instructions provided in a PDF. For any questions, please reach out to us by writing to hwsupport@altair.com. Thank you.